So I'm Malcolm Smith. I'm from the wireless BU. I'm actually part of the innovation team within the BU. So my job is to look at the future. So today I want to talk about any products, roadmaps, or features. So there'll be purely a discussion about the future architectures and technology that we see coming down the next couple of years and how we approach the market with those architectures. So I'm actually Canadian too, like Dave Zacks, but I'm also proudly Texan as well. I noticed a few Texas jokes before the session began. Yes, we do have pickup trucks, but no shotguns, not in the back. AR-15s, but no shotguns. Just to clarify that. Okay, so
we're good now. We're good.
Okay, now we're good. Okay, good. All right. So I'm talking about some of the trends in the industry, Wi-Fi, and also trends across the enterprise and service provider space. Cisco is an enterprise player, but also a player in the SP space as well. So talk about how those two trends may actually come together at some point, and what we Cisco would approach the market given those trends. Okay. So two trends we've all focused on are cloud. Everyone's going to the cloud today. So my data, my Cisco data, is not in a data center on campus, it's in the cloud somewhere by a third-party provider, or even hosted by Cisco itself. That's one trend that we're focused on. The other trend is the workforce is mobile today. Employees are no longer tethered to a desk. I work at home in Dallas. I go to Starbucks in Dallas. That's my office, okay? I come to the office almost never. I come here for the office. So I'm mobile. Most employees are not mobile today. About one half of all traffic is actually on the public internet, not on the enterprise campus at all. Very interesting trend. So that means your data traverses over a enterprise network, but most often a public network, cellular network, 4G network. That's the most common transport outside of the office for your data. Let's go in the cloud. So what does that mean? Well, first of all, it means that mobile operators recognize this trend. They know that data for enterprise is going across their network. And they want to cash in on that trend. They want to deploy technology to meet enterprise needs. Okay? So what they're doing is, traditionally, cellular is based on voice. Make phone calls, my iPhone. It was voice, it became data, became packet data, became 4G LTE, high-speed data. That's the trend. But the new inflection point for cellular is what we call 5G. Now 5G is that terminology thrown around by multiple vendors. It means a few different things, but what it means to us, Cisco, is that mobile operators like AT&T, Verizon, etc., are focused on enterprise as our next customer. So enterprise is a new target market for mobile operators. They're doing it with different techniques. One is they are definitely targeting, in solving the 4G coverage problems today. They want to solve indoor coverage problems. If I make a Wi-Fi call or a voice call outside the parking lot working in this building, most often that call will drop in this building for various reasons we'll get to, right? So we want to extend the outside coverage indoor to make the voice and services that they have offer to the enterprise campus. With also look at new use cases, new enterprise use cases. The most common one we see is simply extending enterprise outdoor, right? If I am in this building with a very good SLA, QS, management DNA, of course, I step outside this building, I have no SLA control or security control of my session. I have to go in a public internet as a consumer of cellular services and hope that the QS and security is appropriate for the enterprise services. Today, that's all done basically via VPN for security, but nothing for policy and control. It's all governed by the mobile operator's service to me as a consumer of cellular services. So that's one thing they want to fix. Provide better services to enterprises for better QS and better policy management outside on the mobile networks. So those are two trends that we think are going to impact the enterprise networks, because obviously Cisco plays in the enterprise space, and we will offer the best solution to enterprise customers. So this is 5G in sort of a nutshell. A lot of verbiage here. But there's two key pieces of 5G I'll point out. One is that 5G is about new radio technology, new radios. new base stations, okay? Faster, cheaper, but more critically, in the world of mobile operators, they're using unlicensed spectrum, 5 gigahertz spectrum. That's Wi-Fi spectrum. So they're using unlicensed spectrum to deliver services to the customers and charging for it, okay? Right now, Wi-Fi is essentially free. The spectrum is free. Most places I go, it's virtually free directly to me as a consumer of that bandwidth. But licensed spectrum is definitely costs you money. It's definitely chargeable, billable, and operators want to use the same spectrum Wi-Fi uses for billable services. That's great for them. They make a lot of money from billing for service over unlicensed spectrum. The other thing they're trying to do, but more fundamentally, is if you look at enterprise service today, almost no one in enterprise uses what we call private LTE services today. If I'm an enterprise like Cisco, even I don't have a private LTE service. I have no control over my service in the cellular space as I leave this building. It's all controlled by the MNO. There's no SLAs, there's no security contacts, nothing at all. Even though you could purchase that via what they call APNs, right? Private APNs, private LTE, that's viable today. But the problem that the 5G operator has is that won't scale. I have to have a distinct policy, distinct contract for every single enterprise in the world. And today's model with centralized core network that operators have, that will not scale to millions of enterprises. It won't scale down. You have one or two different rate plans for consumers, but beyond that, there's no way to scale down to the millions and millions of enterprises that want distinct security and QoS contracts. Right? Think of it as SLAs. So that's going to change with 5G. With 5G using virtualization and automation technology to provide what we call slices. So think of the 5G network as being a 4G network sliced per enterprise customer. So if I'm like FedEx and I have trucks out in the road, I can buy a slice of that 4G network. So no matter what a truck is, what my employees are, I got guaranteed security and QoS slice for my employees. That's what's coming with 5G. Now, that's very cool, right? Now we have a way for enterprises to buy guaranteed pieces of bandwidth and security assurances from mobile operators. That's fantastic. That's only outdoor. How about indoor? And furthermore, how do these things combine? Right? So if we compare the motivations of 5G around openness and virtualization and cloud and slicing, and compare them to DNA, which Dave Zax discussed for 45 minutes, you see they're very similar. DNA is built about concepts of virtualization, virtual functions, open APIs, cloud-based enablement. So those are all functions that 5G is planning to offer in 2-3 years, but it's something that DNA offers today. So we actually think that the values that the mobile operator are trying to deliver in terms of scaling down to enterprise and the capability of DNA today to offer virtualization, policy, control, automation can be brought together in a way that's useful for enterprises. I'll show you what that is in the next slide. So here's what it's sort of describing. So enterprises have a well-defined, well-designed branch network, campus network that's very functional. Delivers the QoS security you need today. Okay. Now outside, the SPs have a built-out network for covering outdoor spaces, traveling, versus mobility use cases. That's all fantastic. But what's missing is when I go outside the building, who am I to the SP? I'm not a Cisco employee anymore. I'm simply Malcolm Smith, a consumer. That's all I am to the SP. That's going to change with 5G when we enable the APIs between DNA and the 5G core to interact. So when I go outside this building, I'm no longer Malcolm Smith, the consumer, I'm Malcolm Smith, the employee of Cisco. And that means that I get special treatment in that network. Okay? I'm an employee, I'm a Cisco employee. That's my identity. The other aspect that's going to change is the policy will go with me. If I have a DNA policy for my services inside this building, in this campus, enterprise network, that policy will follow me outside to the cellular network. The policy could be security policy, ACLs and various restrictions. It could be the QoS policy. I get 10 megs of bandwidth, I get low latency. That policy follows me outside. And it goes both ways, right? So if I'm a cellular subscriber, I'm a Verizon customer, I come here, you come here today as a guest, okay? You're a guest, but you're also a customer of MNO, Verizon, AT&T, whatever else. What would be cool if the SP could extend their cellular slice into this DNA network right here, so you get a better experience with your cellular voice services, right? That's a big problem today, right? Wi-Fi calling was turned on by most mobile operators. However, the experience varies. In some networks, Wi-Fi calling works very well. There's QoS, there's bandwidth, there's SLA all the way to the PDSN in the core network. But in most cases, that's not the case. The firewalls will IPsec. There's no QoS. You're on a guest network. You're not your best effort. You're dropped. You're scavenger class data. So that's a problem with Wi-Fi calling. So those problems can be solved today with DNA, because what we're going to do is we'll link up the SP core network to DNA to exchange policy, right? For your flow, your Wi-Fi calling session, your voice session, that gets us a very high treatment of QoS. That gets the gold, platinum treatment of QoS-wise. And the last thing is what we call controller visibility. So when I go outside, in this building, IT no longer knows how my service is performing. They have no clue, right? If I can't attach to the Starbucks hotspot, if I can't get on the network via other means, they have no clue that that's happening. So the other problem we're solving is visibility and control by having the SP network and the DNA exchange analytics and share information real time about my sessions. So they can diagnose the problems that are occurring and solve them in real time. So extending DNA to be a multi-domain solution with the SP as a peer to the enterprise. That's the concept here.
So you were talking about it works both ways.
Yeah.
So one of the problems that's been inherent in cellular networks for a long time is sort of that QoS guaranteeing, access to the medium. First responders ended up with FirstNet, strictly because cellular companies couldn't say, hey, we're going to classify you as, first responder or, somebody who really needs access, and they'd hit a cell tower in an event of emergency, and all of a sudden there's no QoS value. It's like, oh, well, you're a Verizon customer, but we can't.
That's correct.
And does that transfer both ways? So you as a Cisco person, when you go outside and you now are on a 5G service provider network, does that QoS, is there a QoS, and does it transfer back and forth?
The QoS transfers back and forth. The slice, we call it the slice. The slice goes between the outside network, the 5G network, and the enterprise network. In DNA, we call a slice a segment. So inside a enterprise campus, we call a segment. That segment maps to a slice.
Okay.
Corresponding QoS capabilities negotiate between the SP and the enterprise.
And cellular networks can honor that?
They can. Well, 5G,
will they honor it?
Well, they will, because you're an enterprise customer, and you are paying Verizon for an enterprise private service.
All right.
Okay.
This is a service offering from them. So my question is, what scale does this even get to before it makes sense? Is Cisco going to then have a Verizon link, an AT&T link, and a T-Mobile link, and a Sprint link, and for every country in the world where you have a thing, have a negotiation and a interaction, or is there some clearinghouse in between that's going to make this work?
You pick up a very good point. I mean, conceptually, you're right. Enterprise would have to have at least 2 or 3 agreements with different MNOs, right? As they do today for WAN. So that doesn't change. You still have to negotiate these agreements. DNA won't solve that problem for you. That you still have to negotiate some sort of rate, right? A clearinghouse is a possibility, because definitely there's going to be a lot of enterprises. like a
Or
million
smaller,
enterprises.
just
Right.
pick a hospital. It might have 2,000 APs. It's a big hospital, but in this, it's small. I mean, and M&L is going to look at a single hospital and go, "Oh, you're going to have to pay us, the $1 million you'd have to pay us to put in DAS just so we could even do this inside your building."
So here's good point. So, and I'll talk to DAS in a second, but actually I'll do it now. So DAS is only there primarily because of, number one, SPs don't trust Wi-Fi calling in buildings, generally.
As they shouldn't.
Right? Okay. Right. We'll talk to that in a second. Number two, for FirstNet purposes, they want to have their own network. Right. So you still require some cellular connection inside the building. Okay. We can solve one of those problems. We can solve the Wi-Fi calling sucks in the building problem. I'll get to that in like 2 slides. But we can't solve the FirstNet problem. That's the pure regulatory problem. Right.
So as a customer, maybe I'm not getting this correctly, but as a customer, it sounds to me like I'm going to pay a provider more money to use my network, my DNA center, to provide their services. Am I wrong?
That's the outside in scenario.
Right.
That's when you no. So in that case, actually, we talked to many SPs, and most, if not all of them, would not be charging for that access. They want the access. So you're getting it for free, or you can negotiate something through your contract.
Right, but
generally
ultimately,
speaking, it's free.
but ultimately, to use that, right, I'm going to be paying for that slice of some sort, right? So I'm going to be paying for a service on the back end.
If you go outside.
Okay.
Right. If you go outside. Right.
And when you go outside, is it still metered under this
It
relationship?
could be metered or a bulk rate, whatever the MNO wants to do today. That doesn't change. The fact is today you simply can't do because of there's no QS support. But how they charge for it is up to MNOs. I'm not going to make a claim of how they would charge, but that's their choice.
Yeah, and I guess that's been my struggle with this all along. Is it really does sound like we're solving their problem, but ultimately this is going to be something that we end up paying more for in the long term. Like that's what I'm seeing.
Yeah.
Well, everybody wins except you.
Exactly. Right. Yeah. Well, but is it really right? Because we're now putting more clients with more demands on the network that requires a greater SLA, right? So we're going to spend more money on our own infrastructure as well to augment the service provider we're already paying to provide a service that ultimately they can't provide because they're coming to us for help.
But now you're getting better service from the provider, so right? So where do
As
you?
long as you're
As
on
long
that
as
provider.
Yes.
yeah.
Yes. So
Now you need multiple providers.
well, yeah. I mean, naturally.
So I guess am I saying this correctly or have I missed something?
Well, I think what you may have missed is that certainly preferring coverage outdoors, you'll pay for anyway. You're paying for it anyway today.
Sure.
Right. That's not a difference. You'll pay more perhaps to get better SLA, for sure. You get more, you pay more. Nothing's going to change there. Now, allowing the SP to provide services inside your building, that's your choice, right? And for the customers we've talked to, most enterprises would not charge the SP for that. They would simply do it because it gives their users a better experience. Simply.
I've worked for an EDU, a large college in the South, and that's the complete opposite approach that we would take. Because for us, it's an enormous additional cost to make sure then that all of your buildings are blanketed properly and things of that nature, right? And at the end of the day, your burden is the cost of doing that, just to allow them to have better service in your building. So it all comes back to a cost thing for a lot of customers.
Right.
Now, larger enterprises, with much more funding and things like that may not make a difference, but, to a lot of users, it does matter.
Yeah. Yeah, absolutely. And I'm not trying to solve all those problems, but
Oh, yeah, of course not.
Sure.
And I just wanted to be certain. I think that's what we're kind of all working through. This is where at what point are we assuming the responsibility for the network, and then of course the cost that comes with that. And it sounds like there is a proper understanding there that we are going to be taking on that responsibility and the additional complications that come with it.
Right. Now, the advantage we have is that With DNA, that becomes automated, right? There's no manual configuration, manual process to validate that your indoor services will work for the SP. That's all part of the DNA architecture.
Well, how do you escape the matrix, right? You said now you leave the building and you're still part of Cisco. When do you get to go home? When do you get to not be part of Cisco? You know what I'm saying? Is there a toggle?
That's a good question. I don't know. I know that this phone.
You're not getting paid enough.
I know that.
Going where I think
I know that
it's
no matter
going.
where I am in the world, someone at Cisco emails me or calls me on this phone. So I'm not sure I skip the matrix anytime soon.
Airplane mode.
Airplane mode. Yeah, exactly. Yeah. Okay. And so this is our strategy. So whether it's outside in, inside out, the strategy really is to extend DNA to the SP cloud. Have the QS, have the slicing match outdoor in, and then with Wi-Fi, provide a better experience indoor. I'll talk to this in a second, but the technology that we're discussing is going to be on 11AX. 11AX is technology that's coming down the Wi-Fi pipe. It will allow us to deliver these SLAs. That's the bottom line. Today, it's hard to deliver SLAs over Wi-Fi, right? Depends on density of the building, user activity. Very hard to achieve SLAs with Wi-Fi today without real engineering.
So DNA in the beginning conversation has limits right now, 4,000 APs, 20,000 clients, and it's expandable. Now you bring this into it. Is this another copy of DNA devoted just to this?
No, it's
How
the
does
same
it fit
DNA.
in?
It's just all it has is a connection to the API connection to the SP network.
So
They're simply a user of DNA as a service.
did those user
more
limitations from the wireless also come into 5G? So are you now put in that same box now that you're running 5G and wireless?
And are you a client against the overall client count?
Yeah, so you're think of it as the mobile network is simply a consumer of a segment. The segment goes over across WLAN, switch network to the WAN, over to the core network. You're extending your segment over to the 5G core.
Understood, but I'm saying, are you one of the 20,000 clients that copy of DNA can support at that point?
Yeah. So right here, the user is still you, it's still me, right? I have a device here. It has a Wi-Fi interface. In this model, the Wi-Fi interface is right here. It's the same client, same user.
So if you have a significant number of mobile users, it counts against your overall DNA user.
Sure. If you allow any guest to enter the building here, then yeah, your client count will go up for sure. Yeah. So.
Now all of a sudden you have to support users that hadn't been on your network before then. It's not just a historical thing of, I mean, you have a lot of users who don't use Wi-Fi. They're like, oh, Wi-Fi, especially guest Wi-Fi is, insecure. So I use my cellular everywhere I go.
Yeah.
And not only do you have your cell phone, you got your, LTE tablets and laptops and hotspots. Now all of a sudden one user, not only do they have all their Wi-Fi stuff, now they have all their cellular stuff. And from a scaling standpoint, I mean, I think you could burn through the 20,000. I know I could in, minutes.
So
That's why you buy another box.
There you go. Thank you.
so
Solve my problems.
So it's interesting you mention that because guest onboarding is a problem we definitely recognize within Cisco. And there's a technology I can't talk about today, but in the future you'll see technology that will solve that problem for us as well. Because guest onboarding is required to enable you to offer services to the SP. If you can't get in this building and get on the guest Wi-Fi network without touching any buttons, without getting a password or a portal, you can't offer service to the SP. Pure and simple. So we have a guest onboarding solution that we'll discuss later on that will solve that problem for you.
I guess it's not really more of an onboarding question, it's more of just a device count. Because if you have users who don't traditionally use your Wi-Fi system, and now all of a sudden you're going to offer that, so you have the onboarding, you have all this stuff, the counts that you would normally count, you look at and go, I traditionally have 15,000 devices, so I just need one DNA, appliance.
Yeah.
And then you start doing this, now all of a sudden you didn't know about the other 8 to 10,000
It's about
clients that were
It depends-
cellular only, now you have
Yeah.
to then account for that.
It depends on the venue, but we estimate that about 10% of all clients are guests, and the rest are employees. That's their average.
And
Yeah.
and it works until you go into, LPV, large public venues, and then that model.
Well, but in that case, they're all guests to begin with.
Right.
Right.
But they don't use the guest Wi-Fi because it's so insecure. They'd stay cellular.
We're solving that problem. I want to tell you that. That's being solved. But I can't tell you how right now, but with that problem we're solving for sure. Because we see onboarding in public venues being a major barrier to Wi-Fi adoption.
It's still.
Thank you.
All right.
Yeah. Thank you. I've been told with 5 minutes left, so
All right.
we can continue offline. The email is available to do that. So I'll skip right to maybe the other discussion. So one of the reasons why mobile operators don't like Wi-Fi is because it's different than LTE, different characteristics, different properties. Okay, the one property that LTE provides that Wi-Fi today can't provide is what we call determinism. Okay, if I get on a LTE call outside this building, a voice call, pretty good idea that it'll sustain number of handoffs. You go in the car, out the car, walk to Starbucks, the call will stay up. Okay, they have a different way of managing resources in LTE. They have lots of spectrum, no interference. That's fantastic. Okay, now in Wi-Fi, we don't have that luxury. We have unlimited spectrum. It's free. There's lots of it, but it has interference. So that's one area where Wi-Fi falls down compared to LTE. And one reason why LTE providers like Verizon and AT&T don't like to use Wi-Fi for some venues. But that's going to change with 802.11ax. We had this discussion with many mobile operators in the Wireless Broadband Alliance, WBA, okay? And most now agree that 11ax, when deployed, would be good enough or close enough to good enough to LTE to provide services that they're familiar with, like voice and real-time video. So if we compare, Wi-Fi to 4G and 5G, which is what this graph is shown here, we said the only major area where Wi-Fi is deficient is in the high-speed mobility case. Okay, if I'm driving 2 miles an hour down the road, or 50 miles an hour down the road, Wi-Fi isn't your best choice for connectivity, right? Wasn't designed for high speed. Even with the outdoor APs that cover this campus, it's not designed for high-speed mobility. It's simple that LTE will dominate in that use case. However, in most other use cases, right, density, throughput, per user density, Wi-Fi definitely beats LTE. And that's why LTE wants to use unlimited spectrum. They want to use that free spectrum to get more capacity. But Wi-Fi is, far ahead in the unlicensed game. Been this for a long time. So Wi-Fi will probably be the dominant unlicensed spectrum technology we see in the next 3 to 5 years. Okay.
So why would I want to use this versus CBRS?
Good question. Okay, so CBRS is a technology, it's LTE technology.
Sure.
In a certain narrow band. And in the US, it's what we call lightly licensed. So I can buy a piece of it conceptually, but really I can't. And what happened in the US was they put it out for auction, and all the MNOs bought all the tracks. So now, if I want a piece of that spectrum, I got to pay MNO for that spectrum. So I can't personally get that spectrum anymore.
So if I have to pay them for that and they don't have to pay me for my 5 gig access, why would I just not utilize another device that used CBRS versus allowing them onto my network?
Yeah. So the use case that CBRS is solving is limited right now to things like IoT. That's how it's used today. Outdoor, rural, suburban coverage, right? That's what it's used today. Indoor, I think it's still TBD how that'll work out. Right? The game isn't imminent. The Mark hasn't decided how that'll go there right now.
Yeah.
Outdoor for sure, but not indoor. That's not how that'll work out.
Is Cisco doing anything around CBRS either behind the scenes or
We're
if it
part of
can
the
be-
alliance, and we're definitely tracking the development of the market. But I said the indoor piece, not sure where it's going to go.
Okay.
Will it be enterprise friendly or SP friendly? Maybe SP friendly, in which case enterprises don't have a way of getting spectrum,
Okay.
so they can't play, essentially. So a quick note on AX. So this is why we like it within Cisco, why SPs like it within the MNO community, because it delivers, a lot of speed. That's fantastic. Who cares, right? What it really delivers is what we call determinism. So it's scheduled uplink and downlink. Now with AX, it looks exactly like LTE. I give you frequency and time slots in the uplink and downlink. Now the AP controls all the client transmissions. If I can control your transmission, I can control latency, I can bound jitter, control interference. All those problems with AC in high density venues and such go away with AX. Okay, that's the real driver for AX.
Did you just say go away?
Okay, that's a bit of a stretch. Okay, make it easy to go away, make it easier to manage for sure. There'll be a point where there'll be a time where AC will still be a sort of a pain in the ass to AX, but eventually AX will dominate, and those problems didn't go away.
So as presented,
So we're still supporting B devices on our network 15 years later?
That was
Yeah.
exactly the point I was going to make.
And the only way to make your statement even partially true is if all the devices were AC,
Nah,
AX.
We have a better solution for that, actually. Here's the solution. Why don't you use our fantastic, tri-radio APs, have one radio for AX and all the cool stuff, and one all legacy crap. B, G, and AC, it's all legacy. Problem solved. We can use band steering or MBO to make sure all the old clients go on the old channel, give them what they want, they can go and make a mess.
And
We
so
don't
band
care.
steering works today, putting all the 5 gig on 5 gig.
So well.
Yeah.
Yeah.